Another option we have for IPv6 address assignment is stateless auto configuration, or SLAC for short. With stateless auto configuration, we are allowing our devices to automatically generate their very own IPv6 address. Our Windows 7 PCs, our Windows 8 PCs are designed to use stateless auto configuration by default, and if they can't determine their IPv6 address using stateless auto configuration, then they will venture off to DHCP. However, our router interfaces are not designed by default to use stateless auto configuration. It's something you have to enable. And since this discussion is centered around obtaining IPv6 addresses from a service provider, let's go to the live environment and look at how we can enable a router interface for stateless auto configuration. Let's focus on R4. R4 is interface fast Ethernet 3/0. If we look at show IPv6 interface brief, we'll see from this output that that interface has no IPv6 address assigned to it right now. We're going to enable stateless auto configuration on this interface. However, before we do so, I want to turn on a debug. The debug I want to turn on is debug IPv6 neighbor discovery. Stateless auto configuration uses the neighbor discovery process for the address assignments. So let me turn that on. Now let's go to global configuration mode, interface fast Ethernet 3/0, and we're going to use the IPv6 address command, and we're going to use the very last option we see displayed, auto config. This turns on stateless auto configuration on the router interface. Now pay attention here to the debug output that we receive. All right, let me shut off that debug, you all, and let's scroll back up and see what's happening. In this particular example, we are receiving a router advertisement from a router out on fast Ethernet 3/0, so the router that our ISP is using. And it's telling us that the prefix is 2001:A:4:, with a length of 64. Now, it's important to realize that stateless auto configuration only works if the length is 64. So if the router was advertising 65 as a length, or 66, or 48, or anything else, it is not going to work. It has to be a length of 64. What will happen now is our router is going to take this prefix and combine it with EUI64 in order to auto-configure its global IPv6 address. So in this case, it's 2001:A:4 with the MAC address of the interface split in half with FFFE put in between, and in the 7th bit from the left side being flipped. In addition to that, it's going to have to perform duplicate address detection on both the link local address that it's generating and the global address. And duplicate address detection makes sure that the address that it is auto-configuring is unique. Nobody else is using it on the network, because we do not want to have duplicate IPv6 addresses. So essentially what's going to happen is the router is going to send out a neighbor solicitation message asking if anybody owns the MAC address for this particular IPv6 address. If nobody responds, then nobody's using that particular IPv6 address. So it's a relatively simple process, duplicate address detection. And what is happening is our router is waiting for no response. If it gets no response, then it knows it's unique, and then it can say, okay, it's good. Everything's great. Nobody else is using it, so I'm going to auto-configure my own IPv6 address on the interface using this particular prefix and EUI64, which results in this right here. So therefore, this is the particular IPv6 address I'm now using on my interface. We can verify that now with the show IPv6 interface brief command. And there we go. We have a link local address now, and we have a global IPv6 unicast address.